Hi everyone, welcome back. Today let's study about tangents and intersecting chords. Look at the circles and straight line drawn here. There are three different diagrams drawn here. In the first case, you can see that the straight line AB doesn't touch the circle or it doesn't meet the circle. In the second case, you can see the straight line PQ meets a circle at two different points. And in the last case, you can see that the straight line MN just touch the circle at only one point, that is at X. These are the three different figures you can see. In this case, the line PQ becomes the secant to this circle. This is called as a secant. A secant means the line which touches the circle at two different points. Here in these two different points, the line PQ is touching the circle. And in this case, the line MN touches the circle only at one point, and this is called as a tangent. The line MN is called as the tangent to the circle. So now let's study some of the results related to tangents and intersecting chords. The first theorem states that the tangent at any point on the circle, here MN is the tangent at any point on the circle, here the point is P, and the radius through this point, this OP is the radius through this point are perpendicular to each other. That means this angle is 90 degree. The first theorem states that the tangent drawn at any point of the circle and the radius through that point are perpendicular to each other. That is the first theorem. Now, in the second theorem, if a tangent is drawn from an external point P to the circle, there are two tangents that can be drawn and these two tangents are equal. That's the first result. When two tangents are drawn from an external point to the given circle, then the two tangents formed are equal. That's the first result. And these tangents subtends equal angle at the center. These two angles are equal. And these two tangents are equally inclined to this particular point. These two tangents are equally inclined. These are the result. These are the second theorem. The first theorem states that the angle between the tangent drawn and the radius through that point is 90 degree. That means angle MPO is equal to angle NPO is equal to 90 degree. This is the first theorem. And here this point P is called as the point of contact. Point of contact. In the second theorem, the tangents drawn are equal. That means PA is equal to PB and the tangent subtends equal angle at the center. That means angle AOP is equal to angle BOP. And the third result says that these two tangents are equally inclined. That means angle APO is equal to angle BPO. These are the three results related to the second theorem. So these two tangents are equal and it has equal central angle. Two tangents subtends equal central angle and these two tangents are equally inclined to the line joining the point P to the center of the circle. Now let's solve few sums related to this topic. Look at the first question. Given the radius is equal to 8 cm for a given circle, calculate the length of the tangent drawn from a point 10 cm from its center. So let's draw the circle first. This is a circle and O is the center of the circle. And we have to draw a tangent to the circle which is 10 cm from the center. The tangent is 10 cm from the center of the circle. So this is the point P here and this distance, the distance of the point P from the center is 10 centimeters. We need to find the length of the tangent formed. So the tangent means the line segment or the line touches the circle only at one point. This point is M and this MO is the radius. Now we need to find the length of the tangent PM. It's given that the radius of the circle is 8 centimeters. So this distance is 8 centimeters. Now as per the theorem we have studied, we can say that the angle between this tangent and the radius at the point of contact is 90 degree. The angle between the radius and the tangent at the point of contact is 90 degree. So this becomes a right angle triangle. Then by using Pythagoras theorem, we can find the length of PM, that is a tangent here. So consider triangle PMO. This is a right angle triangle. By Pythagoras theorem, hypotenuse square is equal to base square plus altitude square. Here the hypotenuse is PO, that is the distance. It is 10 here. So 10 square is equal to, the base is 8 centimeters, 8 square plus the altitude is PM. PM square. So 100 is equal to 64 plus PM square, and rearranging the terms, we get this as PM square is equal to 100 minus 64, and that is equal to 36. PM square is 36. This implies PM is equal to square root of 36, that's equal to 6 centimeters. So therefore, the length of the tangent is 6 centimeters. Look at the next question. Given O is the center of the circle and AB is the tangent at B. If AB is 15 centimeters and AC is 7.5 centimeters, calculate the radius of the circle. Let's draw the diagram first. It's given that O is the center of the circle and AB is the tangent at B, and AB is 15 centimeters. AB is the tangent, this is the point A and this is the point C here. AC is 7.5 centimeters and AB is 15 centimeters. Let's join this to the center. So this becomes a right angle triangle and we need to find the radius of the circle. We don't know the radius, so let's consider it as x. Let x be the radius of the circle. Now here the length of AC is given as 7.5 centimeters. Only this length is given. So this part we don't know. Since it is a radius, we can write even this as radius. Therefore the total length becomes x plus 7.5 centimeters will be the length of AO. Now consider the triangle ABO by Pythagoras theorem. Hypotenuse square is equal to base square plus altitude square. We are using the first theorem that the angle between the tangent and the radius is 90 degree. So here the hypotenuse is AO, that is x plus 7.5 the whole square is equal to x square plus 15 square. Use the formula a plus b the whole square. X square plus 15x plus 7.5 the whole square is equal to x square plus 15 square is 225. Cancel x square both the sides. 15x plus 7.5 the whole square is 56.25 is equal to 225. 15x is equal to 225 minus 56.25. 15x is equal to 168.75. On dividing this by 15, we will get x is equal to 168.75 by 15. That's equal to 11.25 centimeters. Therefore, the radius of the circle is 11.25 centimeters. Look at the next question. The sides of a quadrilateral ABCD touches a circle. Prove that AB plus CD is equal to BC plus AD. So this is a quadrilateral ABCD and the sides of this quadrilateral touches the circle at different points P, Q, R and S. We have to prove that AB plus CD is equal to BC plus AD. we have already studied a theorem that the tangent from the external point to a circle are equal. There are two tangents that can be drawn from an external point to a circle, and those two tangents are equal. So if you consider this particular point A is a point which is an external point to the circle, and AP as well as AS are the tangents. So here we can say that AP is equal to AS. Similarly, BP is equal to PQ, and CQ is equal to CR, and DS is equal to DR. By using that theorem, we can prove this result AB plus CD is equal to BC plus AD. Let's consider the LHS. LHS is AB plus CD, and AB can be written as AP plus BB plus CD is CR plus RD. So this AP can be written as AS plus PB can be written as BQ plus CR can be written as CQ and RD can be written as DS. Why we are replacing this AP as AS and PB as BQ? Since tangents drawn from an external point are equal. That is the reason we are replacing these AP, PB, CR and RD with AS, BQ, CQ and DS. Now let's rearrange this. AS plus DS. I can write it together. AS plus DS plus BQ plus CQ. AS plus DS is AD plus BQ plus CQ is BC, and that is the RHS. This is how we can prove that AB plus CD is equal to BC plus AD. Now this question is for you. You can solve it and let me know the answer. From the given figure, prove that AP plus BQ plus CR is equal to BP plus CQ plus AR. You have to use the theorem what we have studied in the beginning of this class. The tangent from the same external points are equal, and solve it. That's all for today. We'll meet in the next class with the continuation of the same topic. Thank you.